Okay, so I think I know the problem that you're having. And it comes down to remembering what the point of having binomial probability is. Now, we'll talk about it when we get to the next section, but I think I got you. Okay, so 6 footballers are chosen at random and asked to kick a football. The probability of a footballer being able to kick the ball at least 50 metres, meaning that would be the little one eating the big one, is 0.7. Determine the probability correct to 4 decimal places that only the first 3 footballers chosen kick the ball 50 metres. So, this is what I'm talking about. Here is my 6 footballers living their best footballing dreams. Now, if I tell you that only the first 3 kick it correctly and then these guys suck, losers, this isn't part of binomial probability distribution because this just comes down to a regular counting principle. Only the first 3 kick, which means that the next 3 suck. So that's 0.7, he wins, and he wins, and he wins, and he loses. And he loses, and he loses. This is the only one that exists for it. So it's not binomial probability because it is dictated what order they're going to be in. Binomial probability would be more if you didn't care about what order it was. It wasn't only the first 3. If you just said 3 of them kick it at least 50 metres, then it could be this guy, like same order as this, switch these 2 around, or switch this one and that one around. And then that creates the binomial situation where we have any combination of the 3. So all we have to do for part I is 0.7 to the power of 3 times 0.3 to the power of 3, and that is the probability that the first 3 kick it at least 50 metres. Okay, I'll punch that in the calculator. I'm not scared. Now, I haven't checked your answers because you didn't say where you got these questions from. So if one of these is incorrect, make sure you just email me today. I'm doing solutions for specialists anyway, so this is how I live my life now. Okay, so 9.261 times 10 to the power of -3. Remember, if it's -3, that means we're moving the decimal place forward 3 places to make it a smaller number. So 1, 2, 3, it needs 2 zeros. So 0.009, and it says we're rounding to 4 decimal places. So this 2 is going to become a 3. Okay, next question. Exactly 3 of the footballers, the probability that exactly 3 of them kick the ball at least 50 metres. Now, so that could be this guy, and that guy. Or it could be that guy, and that guy. So this is the binomial one because the order is binomial of it. Like it could be any of the 3, but we want exactly 3 of the 6 to do this. So distribution, binomial, BPD because we have a success amount. So we want 3 people to be successful out of the 6 that we're trialing. The probability that you are successful is 0.7. Execute. Okay, so the probability of that is 0.1852, and then we're rounding to 4 decimal places, so then that 2 is just going to stay at 2. So if I'm answering this in like a tech active or tech, it has to be tech active for this. So if I'm answering in tech active, I would state what I put in the calculator just so that like maybe you're like me and you get chubby fingers and press the wrong button. You can still get partial marks for showing what went in the calculator. Okay, at least 3 of them. At least, this is a given. So at least 3 footballers kick it correctly. So that means 3 can be included. Given that the first footballer chosen kicks it 50 metres. Okay, so remember that when we do probability of A given B, This just kind of flips. So it's the probability that A and B occurs over the probability of B occurring. This is on the bottom here, so he's on the bottom there. Now, this question, I think they have, let's see. I don't think it is a given that really. I think you can do this normally. I think I've done this with Brandon. Okay, so at least 3 of the footballers kick the ball at least 50 metres, given that the first footballer kicks it 50 metres. So because they state his position, he's kicking it. He's doing the damn thing. So he's got it. We're not even really concerned with him anymore. So your first option for this, if you want to ignore the given that statement, is now we're just looking, we know what happened to that first guy. He's not even a wonder anymore. So we're looking at, out of the 5, if we want at least 3 of them to kick the ball 50 metres and then one of them is a definitely got it, then we're only looking for 2 more successes because he's a win. What's happening to these jerks? Okay, so then that will be 0.7 to the power of 2 times 0.3 to the power of 3. I'm going to just chuck this in here because, you know, lazy. Execute. Gabby, Poppy. That's right. So there's 0.1323. Okay, if you want to do it using the given that statement, that now means that your numerator, which is made up of your and statement, so that means he's kicked it at least 50 metres, and there were 3 successes, which means that we're still only looking for another 2 successes. And at the bottom here, at least 50 metres. So his chance of kicking it at least 50 metres is 0.7. So this works out to be 0.7 divided by 0.7 because he's included in that top group. And the probability of getting it at least 2. There might be an error in that other one because this should be NCD because we're looking for a range here. We want the lower of the range to be 2, the upper of the range to be 5. Your number of trials is 5 because I'm only trying to prove this second statement still. That's probably the answer that should have gone up here. 0.96922. This is why you should always make sure your answer is correct before you begin the video. And then this one will cancel that to just be 0.96922. If you had done the top statement as... Nah, you still have to do it like that because the given that statement knocks it out from the first position, so you're not looking at the first position at all throughout the question. So you do kind of have to do it like this. This, like I said, would be wrong because it should be N because of the, you know, this statement. That should be NCD, not PD. We're looking for the range of them. Let's hope we go a little bit stronger on the next question. So Laurie is a goal shooter for her netball team. The probability of her scoring a goal is 0.85. In one particular game, Laurie has 12 shots, so then trials equals 12. Determine the probability, correct 4 decimal places, that she scored at least 9. The probability that she scored at least 9 means that 9 is the littlest number. So if she scored at least 9, then that's going to be in this same section, binomial cumulative distribution, where her lower is 9, her upper her upper, there. That one's going to be 9, enter. The next one is going to be 12 because there's a maximum of 12 shots. The number of trials is 12, and her probability of getting the score is 0.85. So her probability, correct to 4 decimal places, should be 0.9078. Only her last 9 shots were goals. So this one again dictates order. If only her last 9 shots were goals, then that means first 3 losers, and then the last 9 were winners. So this isn't binomial, this is a counting principle. So B is going to be 0.15. So 1 minus that gets you the chance of the loss. The power of 3 times 0.85 to the power of 9. Menu. 0.15 to the power of 3 times 0.85 to the power of 9. Yeesh, that's an ugly number. So 7.817 times 10 to the power of -4 is going to 1, 2, 3, 4. So 0.123 zeros, and the 7 will go to an 8. Okay, and then that should be it. If I got one of them wrong, send me the answer and I'll tell you how they get the answer. But just from first glances, that's how I think they did.